Write inequality with transformed absolute function. Well, this video is going to be very interesting. In the last video, we had absolute function without any transformation. Now, when we transform, then it rather becomes tricky. So we'll have a few examples for you. Let me give you examples first so that you can try it on your own while I'm drawing these examples, right? So we'll have a few number line solutions. I'll put 4 here. Now let's see how we can do them. So the first one is when I want to have something in between two values, but the two values are not symmetric about origin. Let us say the two values are -2 and 4. Then what is the way to represent this as an absolute function, right? So that is one thing. And this one is similar to that, but with filled in holes, right? So we just fill it in and write two values, which you guessed it, are not symmetric about origin. So let us say we have -10 and let's say 0, okay? Now here we have this, let's shade in between. So that is a solution on a number line. Now in this case, we'll have something which is greater than. So the arrows are pointing outwards, right? And the solution is, we say less than, let us say 4, and greater than, let's say 6. And here we have similar kind of solution but filled in. Now that is, let us say, in this point is less than -8 but greater than, let's say 2. So these are 4 different examples which we'll try to solve or write in absolute function, right? So the idea here is, as you learn, that the absolute function has these two values which are symmetric about a point. In these 4 cases, that point is not the center point, as you can see. So the first thing is we have to find what the center point is. How to find the center? So the middle point here is, let me call that as M. So how to find M? M is average of the two. So just add them up and divide by 2. So what do you get? So you get -2 plus 4 is 2, 2 divided by 2 is 1. So this point is 1 here. So that is the first thing we understood. Second thing is, how far is this middle point from each end? That is, 4 minus 1 is how much? So that is what we are trying to find, distance, d. So how much is the distance from middle to the ends? 4 minus 1 is 3, right? You will see this is also 3, but negative. So it's -2 minus 1, which is -3, right? So the distance is 3 units from either side. As you understand, for absolute function, it's all positive. Distance is positive, right? So you want to be within a distance of 3. That means absolute function is less than. But where is the center? Center is at 1. So what you do is, you come to position 1 by saying x minus 1. So that is a transformed absolute function. So you moved 1 unit to your left, but you want to be within 3 units away. So that is the way you have to write this. Now I'm sure you can do this one. The only thing is, it will be filled in. So a filled in means less than equal to. Now let me take one example of a different kind here, where the solution is less than -4 or greater than 6. So here philosophy is same. Add and divide by 2 to get the middle point. So the middle point here is -4 plus 6 divided by 2, and this also for us is 1, right? So you get 2 divided by 2 is 1 in this case also. Now if it is 1, then we have to see, well, we got this point as 1. How far or is the first point on either side? It is 6 minus, so d is 6 minus 1, I say 5 units away. And we want to be farther away. That means transform the absolute function, move it to your point 1, right? Which you can get by saying x minus 1, right? X minus 1 is 0, so you moved 1 unit to right, correct? That is what you did. Once you move 1 unit to the right, from there, how far away is your point on the right? The first point is 5 units away, but you want to be more away than 5. That means greater than 5. So that is the absolute function which you're looking for. I hope you get this right? Let's do this one now. So here, find the middle point. Let's say middle point m for us is what? So we'll do m equals to minus 8 plus 2 divided by 2, and that is minus 6 divided by 2, or minus 3. So this time we have moved left by 3 units. Do you see that? Moved left by 3 units. Now that means in the case of absolute function, we'll write that transform function as absolute x plus 3, right? Now if you moved left, you are here at minus 3. How far away are you from each point? So here you're away by 3 plus 2, 5, and here minus 8, minus 3. So you can find the distance as minus 8 minus of minus 3, which is 5 units, right? Minus 5 on this side, and on the other side you can say, well, the other side is 2 minus minus 3, which is plus 5. In absolute terms, it is just 5. Do you see? And you want to go further away, so your answer should be greater than equal to 5. Why greater than equal to? Since they are filled in. Do you see that? They are filled in. I hope you have written the solution for this one. By now, the solution is very clear. You have transformed function and you move left. Center point is at minus 5. So it will be absolute x plus 5 is your function, and you are 5 units away from either end, right? So less than equal to 5. That is your solution. So remember, in absolute functions, when you're talking about in between 2 points or going away from 2 points, the philosophy is get the middle point by adding and dividing by 2, average of the two values, and then find how far the middle point is from the ends. So that is the distance between the middle point and the closest point. And then if it is something between, then it is less than. If it is going away, it's greater than. That's how you do it. Now for you, I'm giving you 2 examples here, 2 more, and rather 1. Because I think they are very critical, may be difficult for you to do if I don't give you help. So here it is. Here it is. And then I have a number line which is kind of like this. Now if these are my solutions, you understand, everything but not 1 point. That is one of my solution of inequality, and this one is nothing but just 1 point. It could be equality also, okay? Represent them as absolute function inequality. Can you do that? This is all real numbers. So that is an exercise for you, and that is normally asked in communication and thinking problems. Think about it, write down your answer. Well, let me give you the solution also. Here you see the whole number line is your solution. So what we can say that absolute x is greater than, what is it always greater than? Any negative number, for example. Do you see that? If I say absolute function is greater than minus 1, you know, all real answers. Absolute function is positive, it has to be greater than any negative number, right? Now, this one means what? Absolute function has all the answers but not this point, and I didn't give you the point. Let us say this point is what? Let us say this point is 5. Now what? If this point is 5 and is greater than everything but not this point, how will you write that as a solution, right? And this one is, let us say this point is 3. Now, how to write them as an absolute function inequality, that is a huge thing to think about. By now you must have guessed that absolute function normally has 2 values, but it can have 1 value at its vertex. Do you see that? So if I transform my function, move it to 0.5, that means I do x minus 5 is greater than 0. Then it means what? It means only for 5 this function is going to be 0, that means equal to 0. Do you understand? But all other places it is greater than 0, and you get this absolute inequality. Do you understand? So that is how you write the solution for this one. And for this, how about inequality absolute x minus 3 less than equal to 0? Less than equal to 0. See, absolute function cannot be less than 0, but it can be equal to 0. If I have to write this as an inequality, then that is the inequality, less than equal to 0. Now at 3, this function is equal to 0. Do you understand? These are the thinking problems which you might get in grade 12. You may not get these problems in grade 10, 11, but in 12, yes, sure. If you're doing IB course, you will definitely get, right? Go through them and try to understand the most interesting examples on writing solutions on number line as transformed absolute functions. I hope you loved it. Thank you and share it with your friends.